Hi, welcome back to LeetCode. In this video, I'm going to discuss LeetCode problem 3331. Find subtree sizes after changes. So, problem statement is that you are given a tree rooted at node 0 that consists of n nodes numbered from 0 to n minus 1. The tree is represented by an array parent of size n, where parent I present the parent of the current node I. Since the node 0 is the root, so that's why the parent of 0 will be minus 1. You are also given a string s of length n, where si is the character assigned to the node I. We make the following changes on the tree one time simultaneously for all nodes x from 1 to n minus 1. So what operation actually we are doing? We'll first of all find the closest node y to node x, such that y is ancestor of node x, and sx, what is the character assigned to node x, and the character assigned to node y, both are equal. If node y doesn't exist, do nothing. If it exists, like there is an ancestor of node x, so that time what we'll do, we'll remove the edge between x and its current parent and make node y the new parent of x. Okay, so return an array answer of size n, where answer I is the size of the subtree rooted at node I in the final tree. Okay, so go to the example, that will be easy to understand. So first of all, we will given a parent. Okay, so how many actually nodes are there? 1, 2, 3, 4, 5, 6. 6 nodes are there. So they mentioned that 0 will be the root. It is already mentioned. And node 1 parent is 0. Okay, node 2 parent is 0. Node 3 parent is 1. Node 4 parent is 1. Node 5 parent is 1. Correct. Now what is the character assigned to each node? First of all, node 0 assigned A, then B, then again A, then A, B, C. Correct. This is actually the tree structure. Correct. Now they mentioned that what operation simultaneously we can actually do. We will do what, that if there is, for this suppose node 4, if we find any ancestor of node 4, that actually character is same, equal to B. So is there any ancestor? Yes, this is on node 1, whose character is again B, both the same. So I will actually assign this. So ultimately this is actually the immediate parent, so that's why this change will not reflect. Okay, suppose node 3, what is the character assigned to is A. Is there any ancestor whose character is again A? Yes, node 0. Correct. This is the immediate shortest, right, shortest distance present this node 0, and whose character is again same. So what we'll do, we will assign this this will be node 1, this will be 2. Now 3 I have assigned what, 3 will be stitched to this node 0, and 4 will be again here, and 5 will be here. So now what is actually this, actually I have actually stitched, character is A, this is A, and others character are, it is again A, this is B, this is B, this is C. Correct. Is there any node for any other node, like for C, node 5, is there any node who's actually any ancestor of this node 5 whose actually character is same? Is there any C present at the parent in this path? No. Correct. So this will be present here. We will not actually change this. For this node 2, is there any ancestor? Okay, this is ancestor, but this change will not reflect because this is an immediate parent. First we will remove the edge, then again we actually stitch this. So ultimately this is same. Any other node for this B? No, there is no ancestor in this path from root to this node 1. So that's why this will be present here. So now what will we return? We will return an answer vector. Like for node 0, how many actually nodes are present in this subtree which is rooted at node 0? This is 1, 2, 3, 4, 5, 6. So this will be 6. Correct. For node 0. For node 1, node 1 is where? Node 1, here actually node 1. How many nodes actually present for this subtree? 3. So return 3 here. Correct. Now for is node 1, node 2. Node 2, only 1, only this present. So this is why our answer will be 1. Now I have done for node 2, node 3 now. Node 3 only 1 node is present. Now node 4 only 1. Similarly for node 5 also only 1. So you can check what is the answer. 63111. 63111. Got it? It is clear how we are getting the output. First of all, structure the tree. Then actually what we're doing, we're assigning the character. Now we have to find out that is there for any leaf level node or any node, is there any parent or is there any ancestor? Ancestor mean from root to this path, like from root to that part. Like this is root. We'll start from here. For any node, actually we'll reach there. We'll check is there any, and ancestor will be what? Like for any, this is actually tree. Okay. So now what will be the ancestor of suppose now this is a tree structure. So for this node, what will be the, what can be the possible ancestor? This is one possible ancestor, this is one possible, this is one possible, this is one possible, but this is not, right? From root to this path, whatever the node actually comes, that will be actually ancestor of that node. So what we'll do, what is the intuition, how can I actually solve this? First of all I will build this tree, okay, initial structure. Now what I'll do, I will start from any one node randomly, like for each node actually I have to do that operation. I will check for this parent, I will go what is the immediate parent of this. So this parent, what is the character present in this? These are both the same. Suppose this is B, this is B, so this is same, so this is the immediate. Suppose this is also against B, but what is the mention? We will only replace with the immediate or the shortest distance node. I will merge this. So this is the shortest distance. So this is distance is 1. Here distance is 2 to reach this. So I will only replace this node only. Okay. So I will just merge this. Got it? Then ultimately what I will do? I will suppose this is not B, this is C, and this is B. So now what I will do? First of all, remove this edge. Correct. Now what I will do? I will stitch this edge, actually new edge. Now this will be merged to this node. Correct. This node will be under this node, actually current parent will be this. Alright, it is clear now. So first of all, do what I'll do now, go to the actual code, it will be easy to understand. So first of all, we will create the initial tree. So what will tree? I will actually check what is the parent, and for each current node, what is the child node actually have. So I am iterating from I is equal to 1 because I is equal to 0 means 0 root, 0 node 0 actually I only know that the parent will be -1. So that's why I am starting from I is equal to 1, node 1. I am storing what is the parent of I have, and I am inserting the current node I. Okay, that means what? I am actually initially creating this structure. Okay, now what I will do for each node, for I is equal to 1, I less than n, I plus plus, because root 0 will be not actually, ultimately there will be no ancestor, correct? Because root 0 is the only the itself is a root. So that's why I'm starting from node 1. I'll check what is the parent of this. I'll check till our parent is not equal to -1. That means what? We are not, -1 means what? We have actually reached the top of that. So that's it. We are not reached the -1. That means we will check if the current character assigned to this node P and the character assigned to this node, suppose this is the node current node, what is the character present in this, suppose C, and this is actually C again. I'll check this node and this node. Is character is both the same. That means what? This will be actually removed from here and it will be merged to this node. So that's why what I'll do, if it is both the same, I'll remove from this current node, current parent. Current parent means parent of I. This will be removed. This will be give us this node. I'll remove from erase I. Erase I means I'll remove this node from this parent node. And what I will insert? I will insert in the current parent, the current node. This will be adjacent of P. Correct. I will actually insert this into this parent node, and I will break from here. Else what I will do? I will go to the if it is not equal, then I will go to the next parent. Next parent means of this. This will go to this. So P will be parent of P. Got it? In this actually for each node actually I will check. For each node, I can replace. It will be replaced. Otherwise it will be in the initial state. Now what I will do? I have to return a vector of integer. That size will be n. Whatever the number of nodes are present in the tree, and initially the number of size will be 0, and I am calling the DFS. DFS what will do? Suppose after this operation, our tree is look like this. Okay. Now what will do? I am starting a DFS. So I will count this here. So our current node will be number of node will be 1. So it will actually store this for this node. Number of subtree will be 1, and for this subtree, for this node it will be again 1. Okay, now for this subtree, what will do? Whatever number of node present in the left side and what is the number of present in the right side, that will be actually add. So 1 plus 1 plus itself is present, so that's why plus 1. Got it? This is from left, this is from right, this is for itself own. Got it? So that's what I'm doing. You can check ultimately what I'm doing. Initially the number of node will be current is equal to 1. Okay, and I am iterating the number of child node or the adjacent node. Okay, so I am calling the DFS function again. I am passing this adjacent node I and the adjacent list and the answer vector, and I am adding the current number of present in the left subtree, right subtree in this one. In there is this is not a binary tree, so that's the number of child can be more than 2. So that's the number of child. I will add number of child in the any subtree. I will add this into the current node, and I am storing into the finally after iterating each child node or child subtree. I am storing the number of total node present in this current subtree here. So 3 will be stored where? 3 will be stored in this node. Number of node will be it will indicate the what is the number of index. Suppose 3 index node number 3 node 3. I am come here, so I will store this into the against the index 3. I will store the total number of nodes in this current subtree and return that subtree into the for the next subtree. For I this from this here actually return the 3 return. I return 3 because 3 node are present in the right subtree. Ultimately here actually I will return 1 and itself 1 plus 1 plus 3. Got it? Ultimately this is 5. Clear it is? And ultimately at the end return the answer vector. Okay, it is clear. So if you need doubt, you need suggestion, you can actually comment on that. If the explanation is clear for you, please like the video. If you not yet subscribe, please subscribe the channel. Okay, I and also have shared the link of this code in the description box. You can actually check this. Okay, thank you.